Welcome to solverfy.
Using the information given in each of the four parts, let's determine the formula of the compound and the structure of the complex ion. So from part 1, we can calculate the mass of chromium present. So the mass of chromium is equal to 0.0203 grams of CrO3, and in 100 grams of CrO3 there would be 52.00 grams of chromium, and this would yield 0.0106 grams of chromium. And let's calculate next the mass percent of chromium, which would be equal to 0.0106 grams over the 0.105 grams times 100%, and this gives us a mass percent of chromium of 10.1% chromium. For part 2, let's use this information to calculate the mass of NH3 present. So the mass of NH3 is equal to 32.93 milliliters of HCl times molarity here, 0.1 millimole of HCl per milliliter times 1 millimole of HCl to 1 millimole of NH3, and we'll times this by the molar mass. 1 millimole of NH3 is 17.04 milligrams of NH3, and we can solve for the mass of NH3 in milligrams, works out to 56.1 milligrams of ammonia. Now we'll calculate the mass percent of ammonia, which is equal to 56.1 milligrams over 341 milligrams times 100%, and this would yield 16.5% ammonia. Now for part 3, let's combine the mass percent values to check if other elements might be needed. So we have 74.53%, which is the percent of the iodine by mass, plus the percent of the chromium, plus the percent of the ammonia. And working this out here, we solve for 100.1%. So this tells us that we're at 100%. No other elements are present. So if we assume 100 grams, then we have 74.53 grams of iodine, 74.53, yes. Let's make sure I've got this right here. Grams of iodine, 10.1 grams of chromium, and 16.5 grams of NH3. Times 126.9 grams per mole. This would be equal to 0.587. moles. And this would be 52.0 grams per mole. It's 0.194. And 17 grams per mole for molar mass of ammonia. 0.971. Divide by the least. So we're going to divide by 0.194. Give me 1. So work out to 3. And this will work out to 5. So our empirical formula here is chromium, NH3, 5, I3. So in this case here, chromium 3 forms octahedral complexes. This means that the compound is made up of the octahedral chromium NH3 5 I2 plus complex ion and 2 I minus ions as counter ions. So our formula based on this is going to be CrNH3 5I I2. We didn't need the results from part 4 for the formula, but let's use them. And so delta TF is equal to IKFM is our molality. So let's solve for the molality first. The molality here is 0.601 grams of the complex over 1.000 times 10 to the minus 2 kilograms of water times the molar mass is 517.9 grams of the complex in 1 mole of the complex. And this would work out to a molality of 0.116 moles per kilogram. So let's calculate our delta TF here. The constant here is, assuming complete dissociation, would be 3. KF here is 1.86 degrees Celsius kilogram per mole times a molality of 0.116 moles per kilogram. And delta TF here works out to 0.65 degrees Celsius. So we have some confirmation here, since this value is close to the given value, and the given value here is 0.64 degrees Celsius, we can say that the formula that we've created in part 3 is correct. So we have some confirmation here with part 4.